Hello, in this question, we are going to be integrating inverse hyperbolic functions. And question 5, it says f of x is equal to 1 over the square root of x squared add 2x add 10. Now, the first thing with this kind of question is we need to get it into the required form for where we can recognize it as the integral of an inverse leading to an inverse hyperbolic. And in order to do that, we need to complete the square on our quadratic. So x squared add 2x add 10. And when we complete the square on this, we're going to go to x add 1 all squared minus 1 squared add 10. Gives us x add 1 squared minus 1 add 10. And that's going to go to x add 1 squared add 9, which we could actually think of as being x add 1 squared add 3 squared. Now, that's super helpful to us because now we've written f of x in a form that is going to be a lot more useful to us. We have x add 1 all squared add 3 squared, like so. So we've just completed the square and we've rewritten it into a form where it can be recognized as using a standard result. So let's have a look in the formula booklet. And we can see here that the integral of this one is going to lead to inverse sine, okay, inverse shine rather, okay. So the integral of 1 over x squared add a squared goes to arc shine of x over a. So I'll leave that visible for us. So if I leave that, where has it gone? Shine there. Just leave that visible so we can see what's going on. And we can spot the pattern of which bit corresponds to which. Our x is in fact x add 1 here, and our a is 3, okay? So using that, when we integrate this, we end up with that this leads to us having the inverse hyperbolic of x add 1 all over 3 add c. That's using the standard result from the formula booklet, okay? So that is when we have got the integral of our f of x, so the integral of f of x, okay? So it's inverse shine of x add 1 over 3. So that's part A done for 3 marks. Now, part B, hence show that the mean value of the function in the interval between 2 and 20 can be expressed in that format. Okay, I might start a fresh piece of paper here. Okay, so let's think about this next bit then. So what we're going to be doing here now is going to be using the formula for the mean value of a function, and that is going to be 1 over b minus a. So the mean value is 1 over b minus a times by the integral of our function. And our b in this case is 20, and our a is 2. And it's going to be the integral of that function between 2 and 20 of 1 over the square root of x squared add 2x plus 10 dx. Okay, which when we work that out, that's the result that we worked out earlier on. So we know that this is inverse shine of x add 1 over 3 in between the limits of 20 and 2. Okay, so we've got 1 over 18 times that. That's perfect. So now we're just going to work out what that is. So 20, so that's going to be 1 over 18, and it's going to be inverse shine of 20 add 1 is 21, and 21 divided by 3 is 7, minus inverse shine of 2 add 1, which is 3, and 3 divided by 3 is 1, inverse shine of 1. Okay, now at this point, the question's asking it for in the form a ln b. So because it's asking in that form, we need to express our inverse hyperbolic in logarithmic form. So if we go across to, again, our formulas that are given in the formula booklet, then we can find that we've got inverse hyperbolics expressed in logarithmic form. So here we have arc shine. This is the one that we're going to be interested in. Arc shine of x is equal to ln of x add the square root of x squared add 1. Okay, so we're just going to represent both of these in that logarithmic form. So let's do this one first. So that's going to be ln of x, which is 1, plus the square root of our x squared plus 1, which is going to be 1 squared plus 1, which is therefore going to be ln of 1 plus root 2. That's that one. And this one is going to go to ln of x, which is 7, and it's going to be plus the square root of 7 squared minus plus 1. Okay, which is going to go to ln of 7 add root 50. Okay, so that's our two expressions converted into logarithmic form. We are taking those away from each other. Now, using the laws of logs, this is going to become a quotient. So we're going to have ln of 7 add, now root 50, I'm going to rewrite root 50 in its equivalent form, which I think is going to, if I'm not mistaken, going to be, let's have a look at that. So just going to go root 50 is going to be 5 root 2. So I'm going to write that as 5 root 2, like so. And that's going to be over 1 add root 2. So we're getting there now. So that's our expression. However, that is not quite in the form in which it is required. So in order to get it into the required form, what I need to do now is I would say I'm going to rationalize this expression by multiplying the numerator and the denominator by the conjugate. Okay, so we're going to just say, okay, we're going to multiply by 1 minus root 2 and 1 minus root 2, just in order to find a different way of writing this that matches the pattern of what they're asking for in the question. I like to use a little grid when I'm multiplying surds, as you may know from a previous video. So 5 root 2, and this is going to be multiplied by 1 minus root 2, which is going to give me 7 add 5 root 2. That's going to give me minus 7 root 2 and minus 10, which when I collect like terms becomes minus 3 and minus 2 root 2. And then let's do the other one. The denominator is going to be 1 plus root 2 times by 1 minus root 2, which is going to go to 1 plus root 2 minus root 2 and minus 2. They cancel, and then 1 take away 2 is minus 1. So we bring those together, the numerator and denominator, which give us that. The minus 1 cancels, and we have 1 over 18 ln of, because this is all minus, a minus, 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 they cancel, and it becomes 3 add 2 root 2. And now our answer is in the required form. And that is the part B to that question done for another 3 marks. So have a quick look at that, check that that's all good. Yes, that's fine, that's correct. I hope you found that useful, and I'll see you in the next video.